that you are going to use, or you can use that equation. V is x over t. So how did I know that? I read the word constant speed. It says a policeman starts his car from a rest just as the van passes him. The police car can accelerate. So police car accelerates, that means I can use equations of motion. Vf equals Vi plus A delta t or whatever. And it reaches a maximum velocity of 20 meters per second. The police car then continues driving at this constant velocity. Now they ask, convert 54 kilometers per hour to meters per second. Carabello, let's start with you. What did you do? And you got? Say again? 15 meters per second. Okay. Then they say, calculate the time it takes the police car to reach its maximum velocity. So for the police car, we have the final velocity is going to be what? 22. 20. 20. The acceleration is 2. They want the time. And we know the initial velocity is 0 because it starts from rest. So you're going to use that equation there. Final is 20 plus. And you must show your zeros. You can't just leave them out. And you get the time to be 10 seconds. Yes? Yes.
I got the time to be 10 seconds, but I didn't use that.
You used this formula.
Yes.
It's exactly the same formula, just rearranged.
Ma'am, if I use the final velocity minus the velocity formula.
It's exactly the one that she just said. But, Atlehang, Karabu, this formula is not on your data sheet. This one is.
So that's why you prefer that one.
Because if you do this one incorrectly, if you start incorrectly, you get 0 points. Okay, now they ask, calculate which vehicle, the van or the police car, is ahead at the time calculated in the previous question. So they want to know when the time, and where do I have space for that? Okay, when the time is 10 seconds, which one is ahead? And when they ask which one is ahead, they ask which one has traveled the furthest. This is your starting point. Which one is where? So we want to calculate the distance for each one. Okay, now the van is traveling at a constant speed. So constant speed tells me I'm going to look at this formula. Now let's say you are in a test or in an exam and you can't remember this formula. You know you have to use another one, but you can't remember because it's a bit confusing. Then what you can do, a few things, is you can use one of the equations of motions that we have, one of those 4 equations, and then you can just put the acceleration in as 0 because it's moving at a constant velocity. Okay, so you put in the acceleration as 0, and there the initial velocity will be equal to the final velocity of whatever. I think this time it was 15. Okay? Here the initial velocity is, this is for the police. The initial velocity is 0, the final velocity is 20. The time we have, the acceleration is 2, and we want the distance. Okay, so if I first look at the police car, then I think most of you used this equation. You could have used other ones as well because there's lots of ways to get to the distance, but the initial velocity there is 0 plus a half times 2 plus times 10 squared, and that is 100. So the police car has traveled 100 meters. If I use exactly the same formula for the van, now you could have used another formula, but you can use exactly the same formula for the van. But this time, initial velocity is 15, the time is 10 seconds, plus 0. Why? Because the acceleration is 0, because it's moving at a constant velocity. So this whole thing changed to 0, because A is 0, so that whole thing becomes 0. And here you get 150 meters. So which one is ahead after 10 seconds? The van. You have to state which one is ahead. You can't just do the calculation. You have to say this one is ahead. Sharp? Alright. Then you had to do question 8. It says that a car accelerates from rest at 15 meters per second squared for 2 seconds on a horizontal road. Calculate that. Okay. So at question 8, calculate the distance covered. So they want the distance. Yeah. Who's mapping me? Right. The distance, they say the initial velocity is 0. The acceleration is 15. The time is 2 seconds. And we don't have the final velocity. So formula independent of final velocity, which is this one. So this is 0 plus a half times 15 times 2 squared. What is it? 4 to 30 meters. Yo. Okay. Then at question B, they ask you, I think, the final velocity of the velocity of the car. So we want final velocity. We have initial plus a delta t. You could have used another formula as well. The initial velocity was 0. The acceleration is 15. The time is 2 seconds. So that gives you 30 meters per second. Yes.
Doesn't the final velocity and initial velocity need to be squared?
It depends what formula you have. You have another formula, v squared equals I squared. Yeah? So it depends what formula you take. But we get to the same answer? Any questions there? I think it's easy peasy still. No, just wait. Say again? The what? Yes to me? Yes.
Yeah, I used like this distance number for.
But you can't use that because this you can only use when you're busy with constant velocity. It's not going at a constant velocity, it's accelerating from rest. So you can't use that.
Thank you.
Sharp? Yes? Okay, then you had to do question 14. Say again? Didn't we do number 10?
We did.
A. 14. Says two cars A and B are moving at speeds of 15 and 30 meters per second in the same direction. They are side by side when both drivers observe an obstruction ahead of them as shown in the diagram below. Both drivers apply their brakes and accelerate at negative 4.5 meters per second squared until both cars comes to rest. Ignore the reaction time of the driver. So it means they like immediately start to stop. Okay, then at question 14 I ask, calculate the time it takes car A to come to rest. Okay, so we have at question A 4.21. You can see this comes from past papers. Okay, the initial velocity of car A was what? The 15 meters per second. What is the final velocity of the cars, Amara? 0 because they come to rest. What did they ask? The time. Yeah. The time and the acceleration is negative 4.5. Are you alright, Atlehang? But like what? Severe hiccups. My nanny believes that if you have the hiccups, you must put a piece of white paper on your forehead. Only for babies. But maybe it works for you as well. Okay. We will see. I think you must see it. I think it must be here. It pulls your attention away from your hiccuping. Right, so acceleration is negative 4.5, so you are going to use this formula. 15, 0 plus negative 4.5 times t. And Umulema, what did you get for your time? She did. 3.33 seconds. Okay. B, they ask, or not B, sorry, 4.2.2. They ask the stopping distance of car A. So now they want the distance, how long or how far will it need to come to rest. So here, again, you could have used a lot of different formulas because now you have a lot of different information. Plus a half times negative 4.5 times 3.3. Did you use this one, Trust? Okay, so let's see if we get to the same answer. What did you get, Trust? Good. I got 24.999999999, which means 25 meters. Chop. Okay. Then question B, they ask, which car, A or B, has the longest stopping distance? Support your answer with calculations. Okay. So now we know for car A, this is car A, it needs 25 meters to stop. Okay. Let's see car B. How far does that need to stop for car B? What information do I have regarding B? I have the initial velocity. I think it's 30. Yeah. 30 meters per second. I don't have the time it comes to rest because it will not be the same as car A because they're driving at different speeds. I want the distance. The final velocity is 0 and the deceleration is negative 4.5. So now you're going to use this equation. 2a delta x and Genevieve, what did you get for x?
I didn't use that equation.
Hukumni, which one did you use?
3 separate other equations.
Okay, and what answer did you get?
Not the right answer.
How do you know? Maybe you did.
Because it's so out of proportion.
What did you get?
Now I got like 184 meters.
Oh, okay. I got 100 meters. Okay, let me see what you did and where you went wrong. So the question was, which car has the longest stopping distance? It will obviously be car B.
I just didn't use this equation.
Ideal would have been right. Yeah.
I was thinking, I used different equations, but I wrote them same as
Okay. So there's lots of different ways because there's 4 different equations that you can use wherever, however. Alright. Then question C asks, what conclusion can be made about the relationship between speed and stopping distance? Speed and stopping distance. Karabo, what did you say?
I said the higher the speed, the longer the stopping distance.
Yes, so you're going to say they are directly proportional to one another. You're going to say stopping distance is directly proportional to speed. Have you stopped hiccuping? Do you still hiccup? My magis. You see, it works. I also did not believe it, but it does. My nanny does it. Yes. Sharp? Okay. Now I asked you to bring that book.